Okay guys, so this is the last part of module 9, and so remember in the first part we did talk about K versus Q. In the second part we did talk about La Chatelier's principle, and then lastly now I'm going to be talking about the Bronsted acids and bases. And so the main thing that you do have to know is to know the difference between a Bronsted acid and a Bronsted base. And so with this concept, we're going to be dealing a lot with just hydrogen ions, or the same thing as being a proton, because remember that does have like that positive value. So they're interchangeable. And so let's just break it down into ices and bases. And so with an acid, let's see if these markers work, because they're running out. There we go, acid and a base. And so with an acid, you're going to be donating or giving away your H+. And with the base, you're going to be receiving the H+ instead. So this one is donating, and it's donating to the base, which receives the same H+ that you're getting it. And so you can really visualize this by using an equation. So for instance, if we had HCl plus OH minus going to Cl minus plus H2O. And so this has the H plus, because if you broke this down, this is H plus and Cl minus, right? So let's look at the before and after on each one. So it went from HCl to Cl minus. So you do notice that it actually did donate its H plus because it disappears afterwards. So HCl would be your Bronsted acid, and for every acid you have a conjugate base. So Cl would be your conjugate base. And so now that we know our acid and our conjugate base, now let's look at OH and H2O. So before this didn't have an H+, but over here it did gain an H because it went from 1 to 2 H's. And so it did receive that H that this HCl gave. And so this would actually be your Bronsted base. And for every base, you have a conjugate acid. And so this is really like the best way to know the difference between an acid and a base. So in a lot of the problems that they're going to give you, they're just going to give you, oh, like which is which and so forth. So let's do an example problem on page 189 of your workbook, and we're going to be doing number 1. So if we had CH3COOH plus H2O is going to CH3COO minus plus H3O plus. So remember, let's look at the before and after. So CH3COOH, it went from this to CH3COO. So that H disappeared, right? So since it disappeared, it donated its H+, which means that this is the acid and this is the conjugate base. So now let's look at H2O. So we have, let's see if I find a good marker, H2O, and it went to H2O to H3O plus. So it went from having 2 H's to 3 H's, which means that it received a donation from the CH3COOH. So that means that this would be the Bronsted base, and this would be the conjugate acid. And so that's pretty much the answer to that number 1. So let's just do one more problem from one of the exams. And so one of the exams says that in this reaction you have H2CO3 plus H2O is sent from HCO3 minus plus H3O plus. So remember, you just have to go back and forth between the comparison. So before it was H2CO3, but then it went to HCO3 minus. And so it went from having 2 H's to 1. And so it donated, right? Because it doesn't have as many H's as before. So H2CO3 would be the acid. And over here, this would be the conjugate base. And for H2O, it did gain an extra H, which means that it received it from the H2CO3, making it the base. And this would be the conjugate acid. So over here, what they asked about, and I'll just delete this part, these are the answer choices for that question. So the answer choices they gave you was A, the question that they're asking you is, what is the Bronsted acids? So what they mean by acids is not only the Bronsted acid, but also the conjugate acid, okay? So remember the acid that we identified in this case, which the H2CO3, and our conjugative acid was the H3O+. So the answer involving those two and only those two would be the answer. So in that case, it should have been, I believe, B, which just says the H2CO3 and the H3O+. So if they talk about Bronsted acids, that just means the acid and the conjugative acid. If they talk about the Bronsted bases, then that would be the base and the conjugative base. But most of the time what they do ask for these type of questions is just the pairing all together, and that pairing would be the acid and the conjugative base and the base with the conjugative acid, just how we were kind of doing before. Other than that, that's pretty much the main thing that you do know, that you need to know about in the Bronsted acids and bases. So other than that, if you have any more questions, please feel free to contact me. Thank you.